In this clip, what we're going to look at is normalisation. And normalisation is a process that often frightens people off, but it's a necessary procedure. Basically, what it's aiming to do is to avoid some design errors with databases. And the reason for this is that these errors are very difficult to fix at a later stage. And the type of errors that we're talking about here are things like cutting out duplication and making sure that that data is consistent. So many of these fixes are done intuitively, but there's also a system called normalization to go through these steps sequentially. And with this, normally it is three steps that are used, and these are called normal forms. Now, it can be up to 5 steps that are used. This system was developed about 50 years ago by a mathematician called Edgar Codd, and it was at the time that there were poor relations between America and China, and he used so the term normalization was used in terms of creating stable relations between the United States and China, and he thought that this was an appropriate word to use for what we're trying to do here, which is to create a stable relationship between tables. So, just looking at the screen here, generally we look at taking something that is paper-based and putting that into an electronic database. So it might be something like you see here. So with this, you can make a stab at creating your database, and sometimes people will use the spreadsheet Excel to do this and just throw everything into Excel. But fairly soon you find out there are problems in terms of repetition. And this becomes an issue when you find that you have to do ridiculous things, like if you're recording someone's sale, that you have to put in their phone number, and you just kind of think, what in God's name is going on here? So apart from it being a waste of time, it is also error prone. The chances are that if you have to put in the same telephone number, countless number of times, that you're actually going to make an error with that. So these are some of the issues that we are trying to address. So with normalization, what we're trying to do is, as I was saying there, to create stable relationships rather, between tables. And just as I say that, you might be tempted to think that a relational database is that the term relational uh, is linked to relationships, and it's not actually. It's kind of one of these strange terms. It's actually a mathematical term for a set, in this case, a set of tables. But anyway, so with normalization, what's the problem we're trying to solve? And one is to address the whole issue of data integrity. And data integrity is looking at things like ensuring that that there's correct data in the tables, and that might be, for example, if you had two records of the same customer name, that you could confidently say that there were two different individuals, that kind of a thing. Or if you ensuring that there aren't broken relationships between tables, and that might happen, for example, if you delete a customer, and then there's a record of something that that customer had bought, and now there's no longer details of that customer. So that kind of inconsistent updating can violate data integrity or referential integrity, and we've seen that with our database development, where you ensure that the primary key is is used to connect to another table and that there is a consistency there. So the other problem then, or the other issue that we're looking at with normalization is eliminating data redundancy. And data redundancy is where you're putting in the same details again and again, and that leads to sore fingers in terms of unnecessary typing, and it leads to errors as well. So just looking then maybe at some of the concepts that we're going to need to work through normalization. So the primary key is one, and we have used this. We are familiar with this, and the primary key is a quality with a particular field. And looking at the records uh, in in either of our tables here, the first field in each is in fact a primary key, and there we can see that, for example, in the table salesperson, that the salesperson number, that ID uniquely identifies a record, and if we have more than one person with the same surname, we can differentiate them by virtue of the salesperson number. So the primary key is very important in terms of creating relationships, and we have seen that when we're creating the relationships, the links between tables, that we start with a primary key and link that to a field in another table, and that field in the other table will be called the foreign key. Another concept then that we need to understand with normalization is data dependency. And the idea here is where we look at the fields and we say, well, what is dependent on what? And it's kind of like saying that if I have one piece of information, can I confidently say what the other piece of information is? So, just looking to the top here and to the table salesperson, if I have the salesperson number, I can confidently say what that salesperson's name is and what their assigned sales area is. It doesn't go the other way around, because, for example, I might have a few different salespeople working in the south area, and I can't confidently say that taking one of those, that I will know. If I take one individual from the area south, I can't confidently say what their number is, because they may be one of three people who are assigned to that area. So the idea with data dependency is that if you have one piece of data, can you confidently and accurately say what the other piece of data is? So in the example that you have in front of you there, I have some data dependencies worked out.